William Pomerantz is currently the Vice President of Special Projects at Virgin Galactic, where he helps to extend Virgin's business model beyond commercial space travel by leading the development on the Launcher One orbital vehicle and various research campaigns on board Spaceship Two. William is a member of the FAA's Commercial Space Transportation Advisory Committee, the Professional Development Committee of Women in Aerospace, and is a trustee and the chair of the Board of Advisors for SEDS USA. William is a graduate of Harvard College, the NASA Academy, and the International Space University. Please give a warm welcome to our first keynote speaker of the day, Will Pomerantz.
Thank you. Good morning, everybody. How's everyone doing? Everyone found their way here this morning and didn't get stuck in Boston traffic for too long, I hope. People walked or took the T. It's a better idea than taking a taxi, I can tell you, from recent experience. I am always extraordinarily happy to be here at Space Vision. It is bar none my favorite conference of the year because of you all, because of the students. I want to talk to you a little bit about this conference before I go into my normal spiel and talk to you about Virgin Galactic, because you're at an event that's fairly special. As you may have been learning already, in the space industry, you could go to a conference every day of the year. There are probably far more conferences than there need to be. And when you go to a lot of them, you start to realize, for the most part, it is the same people giving the same presentation to the same audience. I think there are many presentations that I could recite from memory from just having heard them enough times. Which isn't to say they don't have a function, they certainly do serve a function. But I think this conference is a little bit special. When you think about the people who will be speaking to you last night, today, tomorrow, they're here for a different reason. You know, honestly, you are not their customers. Right? And you're not their suppliers, and you're not their competitors. And you will be their employees, but not like tomorrow, maybe a little further out. The people who take time out of their work schedules and increasingly out of their personal schedules to be here over the weekend are here because they are passionate about the future of this industry, and they're passionate about helping young people. That is an amazing opportunity. You have this wonderful self-selected group of people who actually care. And I highly encourage you, take them up on that offer. Make sure you get their business card. Make sure you follow up with them. Send them an email like tonight or tomorrow or Monday morning and say, hey, my name is so-and-so. I spoke to you about so-and-so. I'd really love to stay in touch. Can you give me any advice? I want your job someday. Some people, when you tell them I want your job, will get threatened. The kind of people who are here will get excited. I want you guys to have my job someday. And I want you to do a better job of it than I've ever done, because that's what this industry needs moving forward. So please do recognize you're at a special place. Those of you who are at Purdue, set yourself the goal of doing an even better job next year. I think it's an awesome lineup this year. Kudos to the students from BU and the other schools nearby who are helping out. But I'd love to see Space Vision getting better and bigger every single year. I think we've been on that trend for a while. I'm also really excited, from what I can tell, there's a great slate of officers running for positions in the SEDS USA board. So if you aren't running, consider running next year or throwing your support behind one of the candidates this year. It's important to have wonderful leadership, as we've enjoyed for the past couple of years there. Okay, there's my SEDS spiel. I'll now go and talk a little bit more about what I do at Virgin Galactic. I'll begin with a tiny bit of history, and I'm not going to bore you with it because probably you all know this already. This is just to reinforce the point that human beings have been exploring space for pretty long time now, you know, longer than anyone in this room, almost anyone in this room has been alive. Yet, we've only just begun. You know, some of you have seen me present this before. This is the total number of human beings that have ever been to outer space. It starts with Yuri Gagarin in the upper left. It goes through the current crew of the International Space Station. In the bottom right, they're there in order. You learn a little bit about them there. And frankly, I think for you in this audience, when you see this chart, I hope you get a little bit pissed off, because that number is way too small. And it means that if we continue along current trends, not a single one of you will get to go to space. And that is a goddamn tragedy. Because I won't even dignify the question of asking who in this room wants to go to space. I'm just going to assume all of you want to go to space. Or if you don't want to go personally for whatever reason, you want your friends to go, you want to build something and send that. A system that is not going to enable any of you to do that is a broken system. And I encourage you to go and fix the system, or maybe even better, create a new system. because that's what it's going to take for you to fulfill your personal dreams, but it's also what it's going to take for this industry to live up to the high hopes and expectations that I think all of us have of it. I don't want to belittle the things that are happening in the space industry. It's an amazing industry, populated by truly talented people and wildly inspiring projects. There just aren't enough of them. Not enough of the people, not enough of the projects. It is within your power to amplify both of those things. And that's certainly what we're all about doing at Virgin Galactic. You know, many people came to this realization, I was not the first among them by any stretch of the imagination, that ultimately it is not the job of government space agencies like NASA or ESA or the Chinese Space Agency. It's not their job to enable every single person in this room to go to space. It's not their job to say, well, just because I grew up as a young boy dreaming of space, I should get to do it. That'd be a weird thing for a government to do. Governments are typically in the job of wish fulfillment. It was NASA's job and the Russian Space Agency and the Chinese and others to take that number from 0 to a number greater than 0. And it remains NASA's job, and I hope it will always remain NASA's job, to increase that number by 5, 10, 20 per year with these amazing government astronauts who train for decades to become astronauts and train for years for these specific missions of exploration. But it's not NASA's job to fly you for fun. Nor is it really NASA's job to fly you to make you a better employee someday. They're not the Department of Education, as they are fond of saying from time to time. It's our job as an industry, and it's our job as a company at Virgin Galactic to stand on the shoulders of giants, to leverage the amazing technologies that they've developed, and go and make the space line for everybody. Of course, it's one thing to say that's what we should do. It's a very different thing to say that's what we are doing or that's what we're capable of doing. Our boss is a case in point for that. Richard Branson, serial entrepreneur, not an engineer, not a technical guy, not a high school graduate for that matter, but a serial entrepreneur who has no problem sort of bucking the system and coming up with his own system in something like 60 different business sectors. He grew up wanting to go to space, and he said surely by the time we reach the future, 2015 or something, he'd be able to be an astronaut. Eventually realized that wasn't going to happen. So he registered the name Virgin Galactic in the mid-1990s, saying, if I want to go to space, I'm going to go to space because I'm going to buy a ticket. If no one's going to sell me a ticket, I'll sell myself a ticket, and I'll sell all my friends tickets as well. Registered the name in the mid-90s, went out looking for a system that could actually do this. Remember, he's not an engineer. It's not like he had a brilliant idea on a napkin somewhere for the spaceship he wanted to build. He wanted to go and hire someone to build the right system. Went looking for a system that was both affordable and safe, because it had to be both of those things. Couldn't find something that satisfied both of those criteria, so set the idea on the shelf for about a decade, until this happened. Now, y'all are probably too young an audience maybe to remember this happening in real time, but I imagine most of you recognize this vehicle, at least from photographs and from videos. This is a system called Spaceship One. It was and remains to this day the only ever privately built human spaceflight program. This was built in the early 2000s. It flew to space several times in the year 2004. And the most exciting thing about this was, yes, it looked cool, and yes, it got profiled on the Daily Show, and it got the Google Doodle. Those things are all great. But perhaps most excitingly, this whole vehicle did go from a drawing on a napkin through all of its manufacturing, construction, test, and through multiple flights to space and into the Smithsonian for a price tag of about $27 million. And as you may have learned already from the work that you're doing in this industry, typically in the aerospace industry, $27 million will get you a nice PowerPoint presentation and some deep thoughts about what we might do in the future. It does not typically get you hardware of any kind, and it certainly doesn't get you hardware that humans get anywhere near. But this one did, and that was really exciting, because it means if you can build this vehicle for $27 million from scratch through flight, successful flight, and if you can fly this vehicle for almost nothing for the cost of the N+1 flight, because fuel doesn't really cost anything in the space industry, it's just the labor that costs so much. That means you can sell tickets on that N+1 flight for not very much money. So Richard had long had a business name and an idea and some marketing prowess and not the technology. This group that designed this had the technology and no real plans to commercialize it. So there was a fairly obvious next step here. Let's marry these groups up together and find a way to commercialize this technology, bring it to market. And that's what we're doing. We at Virgin Galactic, and at the time Virgin Galactic was really a box of stationery, and a couple hours a year of Richard's time. But once this was licensed up, the team started staffing up. We hired the manufacturers of the original Spaceship One. We said, hey, go and build something a little bit bigger that we could take to market. Some people think, and perhaps particularly in retrospect, that we should have just put Spaceship One into flight. And there's certainly an appeal to that, but typically if you ask people why they want to go to space, most of them will give the same 4 answers. They want the fun ride on top of a rocket, the sort of right stuff moment of the rumble, and the sound, the vibration, the acceleration. They want unencumbered weightlessness. If you take me to space and strap me into my seat, I will probably feel a little bit cheated. They want the view. If you take me to space in a tin can with no windows and just show me pictures of Earth on a computer screen, again, I'll probably feel cheated. And they want kind of the status that comes with being one of the first human beings to explore outer space. Spaceship One gave you 2 of those 4 things, but not the other 2. You know, Spaceship One did have some windows, but they were there for the pilot to land the vehicle. They weren't there for the passengers to look out. And it was a small enough vehicle that you had to remain strapped in, and furthermore, you had to be pretty tiny. It had to be strapped in basically on your neighbor's lap. So it wasn't a super comfortable experience. So we said, okay, let's scale it up a little bit and build a larger vehicle. Let's go and build Spaceship Two. So that's what was done. This here is a picture of our vehicle pair. We use an air launch system. So instead of launching standing vertically on a pad like the Saturn rockets did, or like Falcon 9 does today, Space Shuttle did, we begin all of our missions at altitude, strapped to the wing of an aircraft. That has a variety of operational and technical benefits. You know, perhaps chief among them, well, even at the altitude of say 50,000 feet, you're already above almost all the atmosphere. So you're not pushing your way through thick soup. You are gracefully spinning your way through the thinnest part of the atmosphere. It also has some safety benefits. If you think about it, for most traditional launches, one of the most dangerous parts of the mission is actually just the first couple seconds of the mission, where if anything goes wrong, you've got fractions of a second to fix it or to get the hell out of town. In an airplane, if something goes unexpectedly, you've got 5 or 10 minutes to glide home and solve the problem all along the way. So just it adds some safety problems as well as, some safety benefits in addition to the performance benefits. So we'll begin all of our missions to space with these 2 vehicles. When you fly to space, and I say when rather than if, because it is my firm hope that all of you fly to space, whether on our vehicle or someone else's, or better yet, on multiple vehicles for multiple flights. Wouldn't that be nice? You'll start by coming and joining us at our commercial spaceport. You'll spend 3 days doing training and preparation. I can say probably everyone in this room is medically qualified, because essentially if you are medically capable of riding a roller coaster, you are now capable of going to space. The days where you would be disqualified for medical hazards as slight as, say, needing to wear glasses are thankfully behind us, at least on this particular program. You'd spend 3 days doing training and preparation, and then in the morning of the 4th day, you get dressed in your flight suits, you meet with your pilots and your fellow astronauts. You'd go and you hop in the center vehicle here in this vehicle pair, which is Spaceship Two, an 8-seater, fully reusable suborbital space plane. You take off under power of our unique carrier aircraft, the White Knight II. I always call it a catamaran because it's a dual fuselage aircraft, so the 2 outer fuselages you see there are the airplane. You'll take off, you'll cruise to an altitude of about 50,000 feet, and then the pilots on board the 2 vehicles, once they've coordinated with each other, will release the spaceship. She'll free fall away from the mothership for just about 3 seconds or so before the pilots on board Spaceship Two will ignite the hybrid rocket motor. You'll get that ride on top of a rocket that most people want so much. You'll accelerate from the speed of a fairly slow jet to the speed of sound in something like 10 seconds. You'll continue accelerating up to a maximum velocity of about 3.5 times the speed of sound, 3.5. And the flight trajectory for this mission, recall this is a suborbital flight. The goal is not to get you from Boston to Shanghai. The goal is not to get you to orbital velocity. The goal is to get you from sea level to as high as we can possibly get you above sea level, as quickly as we can get you there. So the fastest way to do that is a straight line. We fly a hockey stick curve. We fly you basically straight up. That engine will be fired for approximately 60 seconds, plus or minus a couple perhaps, depending on weather, who's in the back of the vehicle, a couple other conditions, before the pilots on board the vehicle shut down the motor. And you will pretty much instantaneously go from loud, rumbly, accelerating, dynamic environment to silence and to weightlessness. And you will take off your seatbelt, and you will be able to float around a pretty large-sized cabin. You'll be able to press your nose up against the window and look out at the views, whether you want to see the black sky of space or you want to look back on our home world from above. See that view that only 551 people have seen before. Experience this thing called the overview effect that I know you'll be hearing more about at this conference. Experience for yourself. See if it's all it's cracked up to be. I imagine it will be. You can do whatever yoga moves you want, or fly like Superman, or crawl around the cabin like Spider-Man, or whatever it is you want to do. And in general, have a grand old time. While you're doing this, our pilots will be activating our unique safety system called the Feather. This is our way of getting back home safely. It is in essence a hybrid system. It makes the vehicle behave somewhat like a capsule and somewhat like a winged vehicle. Those are the two classical ways of getting back home from space, as you know. Each of those systems has their own advantages and disadvantages, but nicely at different points in the flight regime, one of them is always fairly clearly a superior option over the other. So we built a system that is in effect a transformer, and when operated correctly allows you to be a capsule when you want to be a capsule and be a winged vehicle when you want to be a winged vehicle, like when you're coming back home to land. After something like 4 or so minutes of floating out of your seat in true weightlessness, you will get back into your seats, you'll do the feathered reentry, the pilots will put the feather down, and we'll come back home as an unpowered glider, much like the space shuttle did. You will land on the same runway you took off from about an hour and a half after takeoff, but now you're an astronaut. Official, you earned your wings, you've been in space, you've got the memories, and as you can imagine, a whole lot of photographs and video and everything else you could ever want to tell your friends about it. I mentioned at the top of the presentation that 551 people have been to space. We're really excited that we've already sold tickets to about 700 people. Now, 700 tickets would be a pretty slow sales day for our sister companies, Virgin America, Virgin Atlantic. But when you're talking about tickets to space, that's a pretty big deal. We're really, really excited about this and really grateful to our customers who signed up really early on. In fact, many of these customers signed up before we even knew what Spaceship Two looked like, much less how it performed or when it would fly. And I get excited because not only is the number of people large, not only are our earliest adopters on pace to more than double the total number of human beings who have ever been sent to space by our species total, which is already pretty darn awesome. It's also a little bit more diverse a crowd than the group of astronauts who have explored before. If you look at the people who have been to space, it is 90% male. It is overwhelmingly from only 2 countries on this planet. They are all within a very tight range of ages. They're all in peak physical condition. They all come from probably 4 or 5 different academic and professional backgrounds. That means that for the most part, if you pick a random person on this planet, there has never been anyone who looked like him or her in space. And we're starting to change that. It's a long way to go, but we're starting to change that. Our 700 customers hail from about 60 different nations, some 30 of which have never sent a human being to space before. We've got another 12.5 or so customers who are on pace to be the first ever woman from their country to go to space. We've got a number of people who will be the first ever of their profession to go to space. And I think about all these wonderful benefits that I personally have experienced, and probably many of you as well, from getting to meet astronauts, from getting to talk astronauts, from connecting with an astronaut who kind of looks like you, who speaks your native language, who can share the same cultural references, practices the same religion and roots for the same sports teams and likes the same foods. And when you meet him or her, it's easy to picture yourself in that person's shoes. And perhaps that's something that encouraged each of you to major in a STEM field, to get involved in a SEDS chapter, to come to this conference. I get excited about what happens when all the people on the planet for whom that has never been a possibility start to connect with those astronauts. I think that's going to be a really fantastic thing. The majority of our customers are going to space for fun. I should say that funny. All of our customers are going to space for fun. The majority of our customers, fun is the primary reason why they're going to space, but that is certainly not the full extent of our customers. We also have customers who are flying research payloads. We can configure Spaceship Two as a research vessel. It takes something on the order of an hour for us to swap the seats out of the back and put in a rack system that will allow us to fly any of the kinds of experiments that I know many of you have already built to fly on parabolic flight aircraft or on UAVs, on sounding rockets, on high altitude weather balloons. We are trying to offer a platform that sort of fits in where there was a missing rung on that ladder. Many of you have maybe already done experiments in parabolic flight, which, as you know, can get you 20, 25 seconds of reasonably good quality microgravity per parabola, and that's enough to do a lot of really interesting things. What we're trying to say is, okay, what if we took that instead of 25 seconds, what if it was 4 minutes? What new science could you do there? And what if, in addition to giving you just the weightless time, we're also giving you that altitude, so you can look out the window, you can study the atmosphere at, at the 50-mile range or the 100-kilometer range or whatever is of interest to you. A lot of people have started terming that higher level of the atmosphere, they call it the ignorosphere, because it's been ignored for the most part. And we're excited about carrying a lot of research experiments up there. I will say this is a wonderful opportunity for students at universities in particular to fly experiments, because this is sort of within the price range that is feasible for a research university to undertake. In fact, our anchor customer on this side of the business, on the suborbital research side of the business, is NASA. NASA's chartered a full flight plus a little bit more of our vehicle, and essentially has farmed out that capacity to universities, to startup companies, to government labs. I think of the 12 payloads that they've announced for the first flight, I believe 8 of them came from universities. I see at least one person in the room who's building an experiment who's going to fly on Spaceship Two. That's a wonderful opportunity for you to get someone to pay for you to fly something to space. And I can tell you, not only is that fun, that looks really good on your resume when you're applying for jobs or graduate school a couple of years from now. So highly encourage you to look into that. As you presumably all know, we had a test flight accident last year. It's what kept me from coming to Space Vision. I can guarantee you all were having a lot more fun than I was having on that day. That was an emotional setback for all of us at the company. We're a small team. And even though it was our contractors flying this, we all know each other pretty well. We were all friends with the 2 guys on board that vehicle, one of whom sacrificed his life in the service advancing this program. But as we say at the company, that was not the moment that defines us. It's how we respond to that. It's the moment that defines us. And I think that's true for everyone in aerospace. Every company out there has had a bad day or will have a bad day, probably more than one of them. It's how you respond to that will define you as an individual, you as a team as well. In our case, we are in a way grateful that a very extensive analysis of what happened, what went wrong on that day, indicated that it wasn't a fundamental design flaw. The basic design of the vehicle was sound. It was an operational problem, and obviously those are serious, but those are addressable. And we're taking, as you can imagine, great steps to address that in the future. But thankfully it meant that we could proceed with building the second Spaceship Two, which is now essentially complete. This is actually a picture from a few months ago. There are more recent ones up on our Facebook page, or you can check those out. It is basically structurally complete. We've been spending the last couple months going in and doing all the electrical wiring, all the systems like that, in addition to doing a ton of testing on the ground, whether it's doing thousands of pressure cycles on the pressure vessel, the cabin of the vehicle, or it's doing repeated full duration tests of the propulsion system, or avionics tests, whatever the case may be, and preparing for flight. I want to end here by talking also a little bit about the other side of our business. Certainly this program is what we were founded to do originally, and it's what people associate most closely with our brand. But it's now really only half of what we are doing. The other part is taking really the same philosophy and applying it to a different sector, to satellites. Now, obviously there have been a lot more than 551 satellites in space, but I still would contend they're nowhere near enough. And to me, it's a little bit odd. You probably all recognize this. This is Sputnik. Right? And I like that there's a person in the frame here because it gives you a sense of the scale of Sputnik, of how big it was. You can kind of guess maybe how heavy it was, how massive it was. This is launched in October 1957. Picture in your mind's eye any form of electronics other than satellite. How it looked in 1957, how it looks today. Did it get bigger or smaller? Did it get more expensive or less expensive? Did it get more ubiquitous or did it stay the same? Right? Every other type of electronics got radically smaller, it got radically cheaper, and we went from computers being things owned by the biggest universities and governments in the world to every one of you in this room having like 10 computers on your person right now. That hasn't happened in space. I don't see anyone in the audience who owns their own personal satellite. Perhaps I'm mistaken, but probably none of you do yet. And that's because instead of getting smaller and cheaper, for a very long time, satellites got larger and more expensive. They went from smaller than this podium to larger than this stage. And their price tags, even if you adjust for inflation, really went up over time. which meant that none of us can afford our own satellite. Not only us as individuals, but Boston University can't. Probably the city of Boston can't. The state of Massachusetts probably can't, or wouldn't want to at that price point at least. It's kind of a weird trend, I think. When every other form of electronics is on a Moore's Law trend, when you can now go down to Best Buy or Radio Shack and you can buy a computer processor that's more advanced than anything that had flown to space until 10 years ago or so, why weren't the satellites getting smaller? Finally, 5 or 10 years ago, that trend started to change a little bit. The trend actually, I think, in many ways began in universities with folks like yourself building CubeSats, these little tiny satellites, 10 centimeters to an edge. Those things started out mainly as a way just to get people like you some experience. They didn't do a whole lot. They were kind of mini Sputniks, because if you can build something in space, even if all it does is go beep, 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 that's still pretty awesome when you're 20 years old. It's a great experience for you to get. You'll learn a lot. But because of the miniaturization of every type of electronics, we started to be able to fit more into smaller and smaller packages. And now, whether it's 1U CubeSats or 3U CubeSats or smaller satellites like the size of the Skybox satellite here, you can accomplish real missions, whether they're scientifically relevant or commercially relevant or both. I love the story of this company, of Skybox. It was founded a couple of years ago by a few Stanford Business School graduates, or students, Stanford Business School students. And because they were building small satellites that did not require billions of dollars to design or test or launch, they were able to go in the span of about 4 years from the metaphorical drawing on a napkin through building multiple satellites, launching some of them to space, raising about $150 million in venture capital, and then selling their company for $500 million to Google. And that opportunity did not exist when I graduated from my SETS chapter and moving into the workforce. That's starting to happen now. Now, of course, saving a lot of money on building your satellite doesn't mean all that much if it still costs you $100 million or $200 million to launch it into space. So what we're trying to do at Virgin Galactic, much like we're doing with human spaceflight, is drop the price, bring the numbers up. We're not building the most capable system on the market. On the human spaceflight side, we're not going to orbit. We're not building a Dragon. We're building a vehicle that is less ambitious, but much cheaper and therefore much more accessible, much more affordable. Similarly, we're not building an Ares 5 or a Falcon 9 or a whatever else. We're building a more modest vehicle with a much more modest price tag. We announced that we were thinking pretty seriously about this at the Farnborough Air Show 3 years ago now, if memory serves me correctly. Went out looking to see what the market really wanted, make sure we had a service that was actually useful to people who could actually pay for it, which is always a nice thing to have when you're a business, and thankfully got some really encouraging results. So we're now very far along our way to designing a system we call Launcher One, which is an air-launched, expendable, liquid rocket-fueled, small satellite dedicated launch vehicle that's capable of carrying, depending what orbit you're going to, 200, 300, maybe even up to 500 kilograms of satellites up into low Earth orbit. We're not going to GEO, we're not, as a general rule, going to the moon or Mars, but we are allowing you to take your ideas and to get them into space quickly, flexibly, reliably, and perhaps most important of all, affordably. Unlike Spaceship Two, which we hired someone else to design and build for us, we're building this one in-house. We sort of own the design of the rocket from tip to tail. Obviously, we have subcontractors. We've got people who are helping us out, important subcontractors that are doing great work for us, but we really are the system leads, like I said, from tip to tail, and that includes the thing at the tail end of a rocket, which most people are pretty excited about, which is our rocket engines. This is a photo from a test firing of what we call the Newton 3, which is a 7,500-pound thrust LOX kerosene motor. We're firing this out on the test stand now in Mojave. We've also opened a giant new manufacturing facility that is dedicated just to Launcher One. It's in the city of Long Beach, California. It is 150,000 square feet, which is bigger than all of our Mojave facilities combined. I'll put it this way. If we are launching one rocket a year, we've made a very poor real estate decision. And we've invested far too much in the machines, the tools, the 3D printers, the staff. We want to fly a lot of rockets. And we think we're not crazy for thinking we can have really high flight rates, because you can buy 10 of our rockets for the cost of one of someone else's. So perhaps if we say our flight rate may be 5 or 10 times what others historically have done, perhaps we're not insane. I want to end here by talking a little bit about our team. I am privileged to work alongside some pretty incredible men and women. As you can imagine, many of them come from traditional aerospace backgrounds. You know, we've got a NASA astronaut and former NASA chief of staff, and the guy who managed the final dozen launches of the space shuttle, and the lady who was the integration manager for the International Space Station. So we have all those. We have similar people from the United States Air Force and from Boeing and from SpaceX and the other companies. But we've also recognized something that we are trying not to repeat a mistake that I see some other firms that I am familiar with in the industry making. You know, many of you work in the field of rocket science, and you probably have heard all your life all the jokes about rocket science and neuroscience and you being the smartest people in the world. I would encourage you, don't let that go to your head too much. Sometimes we in this business make the mistake of thinking, because what we do is so dang hard, and it is so dang hard, we make the mistake of thinking that no one has ever solved any of these problems before, which is often wrong. A lot of these problems have been solved decades ago by the oil and gas industry, or by the aviation industry, or by the automotive industry. You know, you'll find people who are custom designing parts that you can just order out of the McMaster car catalog. Don't make that mistake. We're trying really hard to not make that mistake. So we have, in addition to the employees that come from the traditional aerospace background, we have people who come in from wildly different backgrounds. You know, the example I always love to use is the guy who designed all of our seats and really everything in sort of the passenger compartment of Spaceship Two. His original job was designing vacuum cleaners at Dyson. Super smart, he's doing an awesome job. He's a diamond in the rough that we found that's brought huge value to our company. I will end by saying we are hiring a lot, pretty rapidly. Mostly engineers, but not exclusively engineers. We have some people from business backgrounds in supply chain. We've got a couple lawyers. We even have a job opening on the street right now for a graphic designer. First time we've ever hired one of those. We now have jobs for young people. I'm sure all of you have experienced the problem where every job you ever could consider applying for requires a minimum of 5 years experience, leading to the obvious question of where the hell do I get that first 5 years? We've got a few positions for people with 0 years. I won't oversell it. It's not a million positions. We're a pretty small company, but we do have some of them. We are accepting applications for interns right now. If you're interested, apply like this weekend. There's not formally a deadline, but we're giving away those positions and it will fill up pretty quickly. And I'll say about our internship program, it is small, it is difficult to get into, but it is an entryway to a full-time job. I think of our interns from last summer, 75% of them now work for us full-time. So if it's your aspiration to come and work for us, I hope you'll take my advice from the beginning of this presentation. There's a reason I'm here. It's not to sell you tickets on Spaceship Two. Although if you want to buy some, I take cash and Bitcoin. You can have some. It's because I want you all to go out and do awesome things in this industry, whether you're working for us or someone else, but hopefully for us. So thank you very much and have a wonderful time here today.